All right, here we go again. So I'm looking at what you've labeled as Part B here, uh, where you're trying to compute the percentage of defendants that are actually convicted. This looks like a good approach. So convicted means that either they were convicted and they were actually guilty, or they were convicted and they were actually innocent. Okay, and then you can use conditional probability as you have here to write that as basically the probability that they are guilty in the case of the first summand times the probability that they are convicted by that jury given that they are guilty. Okay, and that second probability, yeah, you can compute that using a binomial, because basically what you have to do is just think about the 12 jurors as like trials, individual trials. So you can use the Bernoulli distribution. So in the probability that the individual juror is going to vote to convict, given that the individual is guilty, is 0.8. I think we talked about that, right? Vote to convict even if there's 0.8. Yes, that is precisely what we're going to have there. So that's good. So yeah, I agree with that first summand for sure. And similarly for the second summand, okay, 0.35 is the probability of innocence. Then you multiply that by the probability of conviction given that they are innocent, which is unfortunate, but we know that probability. Conviction given innocent is 10%, yes. So I agree with that second summand as well, right? You use the binomial distribution to pull that off. So it wasn't exactly necessary to compute that probability, I guess, from the last, but that was an enlightening exercise, I suppose. We were wanting to compute the probability of a correct decision for an individual juror, which we decided was not quite right up there. But what about a correct decision? Well, it seems to me that you can do the computation somewhat similarly to what you just did for the probability of conviction. Okay, so the probability of conviction, you did it this way. Okay, you have that first summand, that's the probability of convict and guilty, and then you use the binomial distribution to pull that off. It seems to me that the probability of being correct, of the jury being correct, not just an individual, is going to be the probability of the jury convicting and the person being guilty, okay, which is exactly what your first summand is here at the bottom, right? So right here at the bottom, that's what this is right here. I'm moving around it with my arrow right here, okay? Plus, okay, if I want the probability that the jury is correct, plus the probability of them of an acquittal by the jury, and the person is innocent. Okay? And it seems to me that that second summand, the probability of an acquittal and being innocent, well, that's going to be the probability of being innocent, which is like 0.35, times the probability of acquittal given that the person on trial is innocent. Okay? And it seems like that can be computed in a similar way to this thing right here. This was convicted given that they're innocent, but you want the probability of acquittal given that they're innocent. Okay, acquittal given that they're innocent. Yeah, so what would that be? The probability of acquitting given that they're innocent. So what are we going to have to do here? Well, one way you could do that is 1 minus the probability of convicting given that they're innocent. Given that they're innocent. Okay, so the probability of acquittal given that they're innocent is 1 minus the probability of convicting given that they're innocent. But you just computed that right here. So that so the probability of a correct rendered decision is exactly what you have here, but you're just going to replace this sum right here with 1 minus that sum. Yeah, 1 minus that sum. That's it. Okay, so I think that's it. I think that's everything. Okay, in this one. So hopefully that makes sense. All right, I'm going to stop this now.